All right, guys. So this is the second half of the Joints Chapter 8 PowerPoint presentation. So let's keep on going. All right, guys. So we already went over this slide in the first video for Chapter 8, but I just wanted to remind you that in the second half we need to make it through these 6 different types of synovial joints, and so that's what we're going to be working on for the next 3 slides. All right, guys, so the first of the synovial joints that we want to look at is the plane joints. So for exam 3, you want to know the definition that's on the PowerPoint presentation, along with the example that's given in the picture. So for plane joints, movement can occur in any direction, but the amount of movement is slight. So here you're looking at the metacarpals are bones that are in the palm of your hands. If you look at the palm of your hands, those are the metacarpal bones. Your fingers would actually be up here. And then these carpal bones, you see a little bracket, the carpal bones, which are all these guys, these are actually in your wrist. And in between these carpal bones are plane joints. And one of the plane joints is highlighted right there, okay? So if we look at these little boxes, these boxes are meant to represent 2 different bones. The synovial joint would be in there. And then this is just showing you the movement. You can get some side-to-side movement, some back-and-forth movement, but there's not a lot of movement. The movement is slight, okay? So we need to know the definition, and then your example is in between the carpal bones. For the hinge joints, this permits angular motion in a single plane. Your example is going to be between humerus and ulna, which is where your elbow is. So humerus is in the upper arm, ulna is one of the bones in the lower arm, and if you bend your elbow, that movement is angular motion, and that's what they're trying to represent with these little pictures right here. So for exam 3, we need to know the definition, and then we need to know the example of a hinge joint occurs between humerus and ulna. Number 3 is the pivot joint. So this one permits rotation only on a single plane. There's actually 2 examples of a pivot joint that I need you to know. And let's start with this one because you saw it in lab before spring break. So here we have atlas and axis, so that's C1 and C2. Those are your cervical, first 2 cervical vertebrae. And remember we said that if the skull is here, atlas rotates on axis, and that is considered a pivot joint. Another example of a pivot joint that you do need to know for exam 3 actually occurs between radius and ulna. So again, your elbow would be here. These are 2 bones that are in the lower arm. And imagine a person standing in anatomical position. So if you envision a person standing in anatomical position, if you look at their arms and specifically their hands, remember anatomical position means that your hands, the palms of your hands are facing forward. Now imagine turning, rotating the palms of your hands so that they're facing in a posterior direction. If you imagine, or actually physically do that, that rotation is occurring right here at this joint, which is near your elbow, and it's between radius and ulna, and so that's considered a pivot joint, and that's the movement that it allows to happen. Number 4 is a condyloid joint. So here, an oval articular face nestles within a depression on the opposing surface. Angular motion occurs on 2 planes. So we're back to looking at the hand, and again, the metacarpals are in the palms of your hands. Here's the carpal bones in the wrist, and then these bones called your phalanges, these are actually your fingers, okay? So in between the phalanges and the metacarpals are where you get condyloid joints. So this is a condyloid joint in blue, but this would also be a condyloid joint, and so is that one, and so is that one. So condyloid joints occur between the phalanges and the metacarpals. If you look close at it, you do have this articular face that nestles within a depression. Okay, so that's what the joint basically looks like. What type of movement? It's always angular motion. So, think of the elbow, right? Angular motion in this direction and then back and forth like that. Okay, again, pretty straightforward. Then we have saddle joints. So these guys permit angular movement. So angular movement, again, think the elbow, because I think that that's a really obvious example. It includes circumduction but prevents rotation. Okay, so remember, rotation is what atlas and axis do, okay, or radius and ulna. You can't actually do a rotation movement with a saddle joint. Your saddle joint is your thumb. Okay, so think of your thumb. You can get that angular movement, but you can't get rotation from your thumb. You can do a circumduction. What is a circumduction? Okay, well, take your, imagine you're holding a piece of chalk, like teacher's chalk, and you go to the chalkboard and extend your arm out, make it straight, have the chalk in your hand, and then literally try to draw a circle without bending your arm on the chalkboard. That is a circumduction. And if you think about it, you can do that same circumduction movement with your thumb. Okay, so with these saddle joints, you get that angular back and forth movement, that bending movement, like what you see in the hinge joint between humerus and ulna. You can't do the rotation like what you see in the pivot joint between atlas and axis or radius and ulna. But you can do a circumduction. A circumduction, that's a new term for us, but again, that movement, just think of going to a blackboard, standing in front of it, straighten your arm out, no bends in your arm whatsoever. Think of having a piece of chalk in your hand and then drawing a circle, keeping your arm perfectly straight, drawing a circle on the board. That movement is a circumduction, and you can actually do that movement, that circumduction movement, with your thumb. Okay. Now on the exam, we're not going to call it the thumb because that saddle joint actually occurs between two bones. It occurs between trapezium. Trapezium is one of the carpal bones. You will learn this, that trapezium bone is in your lab instructions, and metacarpal 1. So in between metacarpal 1 and trapezium, that's where the saddle joint occurs. That's what you need to know for exam 3. And then we've got the ball and socket joint. So here you can do all the angular and rotational movements. That is permitted. So this occurs between scapula and humerus. So this is in the upper arm, two bones that you're going to see in your lab instructions this week. And so think of your shoulder. Okay, so with your shoulder, you have a great range of movement. You can do all the angular movements. You can do the rotational movements. You can do the circumduction. You have great range of motion with a ball and socket joint. Okay. Okay, so then from here to the end, there are just the names of the different types of movements that can occur at synovial joints. Okay, so here are the different angular motions. And I'm going to give you the definitions of each one of these types of movements, but the definitions are also in your textbook. Okay, so if you just want to turn to your textbook, Chapter 8, all the things that are coming out of my mouth are written in your textbook if you want to look at the information there. And, unfortunately, I can't demonstrate these movements for you because we're doing this online. But I think if you pay attention, these are not complicated movements. Okay. All right. So a flexion, by definition, means you are decreasing the angle between two bones. And so if you consider bones in the arm and bones in the hand, and you move in this direction where you're actually bringing the palm of your hand closer to this part of your arm, you are creating a decrease in this angle between these bones. That is a flexion. The extension is the exact opposite. You are increasing the angle between two bones. So flexion and extension are the exact opposite. A hyperextension means you have increased the angle between two bones to the point where you may potentially do tissue damage. So a hyperextension means you have increased the angle between two bones so much that you risk tissue damage. Adduction and abduction are the exact opposite. They only differ by one letter. There's a B here and a D there. Okay. An adduction, this guy here, adduction means you are bringing body parts closer to center, closer to the midline. They're showing you this little example with bringing the fingers closer into the center of the hand. but you could apply that term adduction to your entire body. Okay, if you start bringing body parts closer to the midline, that is an abduction. You're bringing body parts closer to the midline. You're moving them in a medial direction. So then an abduction is the exact opposite. Body parts are moving in a lateral direction. They're moving away from the midline of whatever you're talking about. So the midline of the hand would be here, and so then maybe you've got fingers moving away in an outward direction, away from the midline of the hand. These terms are not specific to the hand. They can apply to the whole body. You know, if you start moving body parts away from the center of your body, away from the midline, that can also be an abduction. A circumduction, again, we talked about this person's trying to demonstrate, you know, drawing a circle maybe on a chalkboard, you know, out in space there. That's a circumduction. We were talking about that when we were talking about the saddle joint with the thumb, okay? Then we have rotation. We've talked about these, you know, atlas and axis at that pivot joint do a rotation that allow for that right and left rotation of the head. And then remember we said radius and ulna, there's a pivot joint up in here that allows persons in anatomical position, the palm of the hand, to rotate in a posterior direction. That's occurring between radius and ulna. Okay, so those are just two rotations. All right, and so then here we've got, for the most part, pairs of terms. So, you know, I'll give you two terms, but they basically are the exact opposite of each other, okay? So a depression means that a body part is moving in an inferior direction. So imagine this woman's lower lip is moving down. So a body part is moving in an inferior direction. The exact opposite of that is an elevation. A body part is moving in a superior direction. A body part is moving in a superior direction. So if she takes her lower lip and she closes her mouth, like what you see here, she's moved her lower lip in a superior direction. That is an elevation, okay? Then we've got retraction and protraction. Okay, a retraction means that a body part is moving in a posterior direction. I think maybe she's trying to do that with her jaw, like imagine like trying to send your jaw backwards. But a retraction just means that a body part is moving in a posterior direction. A protraction means that a body part is moving in an anterior direction. So I guess she would be trying to like stick her jaw out. I usually do this with my arms. So I usually stand and I send my arms forward in an anterior direction. That's a protraction. If I have my arms beside me and I send them backwards in a posterior direction, that is a retraction. So again, two terms that are the exact opposite of each other. Then we've got pronation and supination, and this goes back to that pivot joint that we were talking about between radius and ulna. Okay, so imagine a person is standing in anatomical position with their palms forward. Okay, anatomical position with your palms forward. If you look down at your arm with your palms forward, ulna and radius are parallel to each other. So in anatomical position with the palms forward, radius and ulna are parallel to each other. And it's easy to get the two bones confused, like which one's ulna and which one's radius. This guy here is ulna. Ulna is always the most medial. Ulna is always the most medial. Ulna is always the most medial. Radius is always the most lateral. Radius is always the most lateral. So ulna is the most medial. Radius is the most lateral, and they are parallel when you're in anatomical position. And in anatomical position, we say that that position is supination, where radius and ulna are parallel to each other, okay? But when you rotate your palm in a posterior direction, like what you see happening here, so here was radius. Radius actually rotates on top of ulna. See how it looks like an X? Radius is on top. Radius was here, and now it rotates on top of ulna. This position is called a pronation. Okay, so when radius rotates over ulna at that pivot joint, that position is called a pronation. So we got supination and pronation. For opposition, if you take your thumb and touch the tip of any of your other fingers, here's the pinky, but it's the same idea for the ring finger, middle finger, and index finger. That movement is an opposition. It doesn't have another term that it pairs with. It's its own movement, okay? Then we've got eversion and inversion, and these only happen in the feet, okay? So when we're using these terms, they are specific to your feet. We don't make reference to these terms with any other body parts. So an inversion means you take the palm or the sole of your foot and you move it in a medial direction. So this would be a medial direction. Inversion means you're taking the palm of your foot and moving it in a medial direction towards the midline of the body. An eversion is trying to take the sole of your foot and move it in a lateral direction. The sole of your foot is moving in a lateral direction. So inversion, sole of the foot is moving towards the midline of the body. In an eversion, the sole of the foot is moving in a lateral direction, so they're direct opposites. And same thing with dorsiflexion and plantar flexion. Just like eversion and inversion, they only apply to the feet. So with dorsiflexion, toes up, ankles down. With plantar flexion, toes down, ankle up. So they're the exact opposite of each other, okay? And with that, we have made it to the end of Chapter 8. So I hope all of that made sense, but as I've said before, if you have any questions about the slides that we covered in this particular video, feel free to type them in the comments section below, and I will respond to your questions so that everybody can see the answers. All right, thanks guys.